Hello everyone, in this video we will be discussing about the final design that our group chooses, as well as the FBD analysis of the crane. Here is the final drawing. The crane has a has a height of 82 cm, and the target for the maximum applied mass is 327 grams. We separate this crane into three components: the boom, the leg, or the base, and the counterweight, including the triangle and the rectangle here. So there is two applied force, F1 and F2. F1 is the applied mass, where we will put the mass, and the counterweight is F2. If you look at the front view of the jib, it has the width of 10 centimeters. Why? Because we follow the width of the base. Since the width of the base is 10, then the width of the jib is also 10. So here are the drawing by section. Why do we want to separate this into three? It is because to find the force of the truss member, we need to start in three different locations. Okay, the first one, we will start off at the counterweight. We make M equals to 0 at this point to find this, whether it is in tension or compression. Then we will use sum of y equals to 0 and sum of x equals to 0 to find this part. Okay, and then starting off this point, we will use method of joints to go from here to here to here, as well as here. Although this one we don't know yet, the truss member, because it still has this jib over here. Then, so because of that, we will move on to the jib. Okay, we will start off here, then use method of joint. Then we boom until this part done. Then we'll move to the base. To find the applied force at the base, we assume that all these four of it is equal. So we use sum of y equals to 0, which is negative F2 and negative F1 equals to 4n. We assume that the applied force is labeled as n. Yeah. Then we use method of joints again to find the truss at this until this part. Now we use method of joints to find this and this section. Since the jib is over here, we can calculate and find all the truss, whether it is in compression or tension.
Okay, now we have reached to the detailed part of the FBD analyze. Now we have known that we divided into three parts, which is the counterweight, the jib, and the base. So the first part that we are going to analyze is the counterweight. Now we are given the known force is F2, and by that we can find the member AD. The way we find member AD is by we put sigma moment at B equals to 0. Okay, so for F2 times the distance to the point B, we minus by the AD sin angle, which is the angle is 19.29 times the distance to moment at B. And then we got the AD is 1.86 Newton. Tension, it means that it's going away from the pin. Now, after we got the moment, we can find the sigma Fy. Sigma Fy is AD sin the angle, which is 19.29 minus F2 since it's going downward, and plus ABy. ABY means there's a reaction force. It's going to the pin that will cancel out the member CB. So that's why we need to find the force member, the force ABY. And then we got the ABY is 0.108 Newton. Next, we can find sigma Fx equals to 0. So for sigma Fx equals to 0, AD cos 19.29 minus BJ. Minus because it's going to the x negative axis. So we got the BJ is 1.76 Newton compression. Compression means it's going to the pin. Okay, after that we can find member BC by using sigma Fy equals to 0 again, but this time we put the ABY minus BC. ABY is positive because it's going upward and it will cancel out the BC since the BC is going negative. So we got the BC is 0.108 Newton and its compression. Now we have find AD, BC, and BJ. We can find the rest of the members. Now we are going to move to the section C. Here, section C, we have CD, CF, and BC. Now we have known the BC force is 0.108 Newton, and we have the unknown is CD and CF. But we can find the angle of CD and CF, which is 38.65. With that, we can use the method of sigma Fy equals to 0 and sigma Fx equals to 0. Okay, for sigma Fy equals to 0 means BC plus minus CD sin the angle, which is 38.65. Minus it means because CD is going downward and going to the left. So for the y-axis, it's going downward, that's why it's negative. And CD, we got the answer is 0.173 Newton compression because it's going to the pin C. Now, for this sigma Fx equals to 0 goes to the same way, means that CF, the unknown force, minus CD cos the angle. Minus because, as I mentioned before, member CD is going downward and going to the left, which is going to the minus x-axis, so it becomes minus. Since we have known the CD force, we can multiply by the cos and angle. We got the 0.135, and with that, CF is 0.135 Newton. Tension because it's going away from the pin C. Okay, next we move on to the section F. Here, section F, we have the member DF, CF, and FG. We can input the same method as always, sigma Fx equals to 0 and sigma Fy equals to 0. Okay, for sigma Fx equals to 0, we have known the CF and we need to find the DF. Same goes to the section C. CF means negative since it's going away from the pin, and DF since it's going towards the pin means that, and it's in quadrant 1, so it's going to the x positive axis. Okay, so now we get the DF is 0.173 Newton and compression. Since the answer is positive, means that our assumption is true, that DF is going towards the pin, so it's a compression. Next, we put the sigma Fy equals to 0 is Fg minus DF sin 38.65, which is the angle that we have found, and then we got the Fg is 0.12 Newton compression. Since we put the assumption is also compression and it's positive, means that our assumption is true. Okay, next we have reached to the section D. Now we have lots of members forces here. We have AD, CD, DF, and DH. So we need to find the rest member here, which is the rope that's going to the jib. Okay, so now we need to put, as always, sigma Fx equals to 0 and sigma Fy equals to 0. Now, we can use sigma Fx equals to 0 only because that we only need to find the force of the DH. So if by using sigma Fx equals to 0 could find the answer, so I don't think that it's needed to find the sigma using the sigma Fy equals to 0. Okay, so now minus AD sin 74.35, which is the angle. So we have found the angle like each of the members. We have find the angle using the tan inverse y over x, tan inverse y over x. So now we got the AD, and then we got the CD, we got the angle of DF and DH. So after that, we got the AD sin 74.35 minus, since it's going away from this x-axis or going to this negative horizon of the x-axis, so that's why it's negative, plus the CD. The reason why it's positive, because it's going to the positive one. This member means that it's going up and it's going to the right. So right is positive for the x-axis, and going up means that it's positive for the y-axis. Okay, so for DF, since it's going to the pin as well, it's going up, but it's going to the left. So means that CD and DF can cancel each other, since the result of both members are also the same. So CD sin 51.33 is 0.135, and DF sin 51.33 is also 0.135. And by that, we can calculate and we can get the member force of the DH, which is 1.81 Newton. And since our assumption is tension, and we got the answer is positive, so our assumption is true, that DH is going away from the pin, so it is tension. Okay, so about the counterweight, we are almost finished. So why is it unfinished here? Because that we still need to find the member force of JK and KG. For now, we cannot find that, since we need to analyze the rest of the part, and then we can find the JK and KG. Okay, so we have reached to the detailed jib FBD. Since we have known the force, applied force, the known force, which is the F1, we can find the rest of the members. Okay, so now before we start, we need to find the angle first. So for this angle, since our height and our width is the same, which is 5 and 5, we can use tan inverse 5 over 5, which is 45. Since 45 tan inverse 5 over 5 is 1, and tan 1 is equals to 45 degree. So okay, so all thrust of the jib has the angle of 45. Thus it does not matter if we use sin or cos, since the result will be 0.707. Okay, so the force that is connected immediately with the applied force is the D1, the point at D, so we can analyze the point at D. Same goes well as the way that we analyze the counterweight. We can use the same method by using the sigma Fy equals to 0, the sigma Fx equals to 0 to find the members for the jib. Okay, so for section D, we have BD, CD, and F1. So the known force is F1, which is 1.61 Newton. And with that, we can find CD and BD. To find BD, we can use sigma Fy equals to 0. And for CD, we can find from sigma Fx equals to 0. So our assumption is BD is going away from the pin, which is tension. And our assumption for CD is the pin is going, the force is going to the pin, which is compression. And our assumption is true from our calculation. So for section B, goes well as this goes same well, which is the sigma Fy equals to 0 and sigma Fx equals to 0. So for sigma Fy equals to 0, since our assumption BD is tension, since it's going to the right and going to down, means that it's going to the y negative axis. So BD must be negative times the distance of the BD, since it's not a straight line. It's not like the BZ, is it on at the x-axis or BC at the y-axis. So we need to find the projection angle, and we got the BC is 1.61 Newton, and our assumption is true for BC, that it is compression. Next, we can find the BZ using the sigma Fx equals to 0. Same with the method. And next we can find the section C as well. Now we have 3 unknown force with 1 known force. We have 2 unknown force and we have 2 known force, which is the BC and the CD. Using the same method as well, we could find the sigma Fy equals to 0 and sigma Fx equals to 0. And with that, we can find the answer for ZC and AC. Since our assumption is true, so the result is positive. That's why ZC is 2.28 Newton and AC is 3.22 Newton. Okay, now we move on to the section D. So now we are currently here and we have analyzed this tree. So for section D, same as well, we could use the same method, sigma Fy equals to 0 and sigma Fx equals to 0. We could find the ZA and the XZ, which is 3.22 Newton. And since our assumption is tension and we got the answer is positive, so it's true that it's going away from the pin, so it's tension. Same goes to the ZA member. Since we assume it to be compression and we got the result is positive, means that it's true that our answer is 1.61 Newton and it is compression. Same goes to the section A, section X, section Y, section V, and section W. Okay, so for now we have reached until here and we still got this left. Okay, so let's continue. Now we have section T, section U, and section H, and section S. Okay, so for now, as you guys can see, we have reached until here and we can see that mostly all of the parts of the FBD have the same pattern. So for the diagonal one, it's going away from the pin, so it's tension. And the Y one, the Y axis one, it's going towards the pin, so it is going so it is compression. And then for the upper horizontal line, it is going away from the pin, so it is tension. But the bottom of the line of the force of the member, it's going towards the pin, so it is compression. Now we have reached until here and we got some additional force, which is the rope that we have analyzed before, which is at the counterweight FBD analysis. Okay, so we are here. So we have 2 unknown force with 3 known force. Okay, same goes well. We use the sigma Fy equals to 0 and sigma Fx equals to 0, and with that we can find the result of HS, which is 1.3 Newton. And our assumption is compression, so and we got the answer is positive, so our answer is correct. We got the HS is going towards the pin and it's compression. Same goes well for the Fx. So with that we can get the answer for member HQ, which is 7.88 Newton. And since our assumption is true that it's going away from the pin, so the answer is tension. Now, after we got the answer, we go back here, means that the rope did not make the force different, did not make the force, the force of the member different. So with that we can continue from the S point at S until the G. So we can get the section Q, section R, section O, section P, section M, section N, K, L, I, J. Okay, so we have reached the end, almost the end, which is the section J, and we still haven't known the section G, the point at G, the force between G and J. So we can analyze from the pin at J to get the answer for the force of the member of G and J. Okay, so for section G, sigma Fy equals to 0, we still use the same, sigma Fx equals to 0. So for sigma Fy equals to 0, we need to put additional force since it's a pin, and as you can see here, it's we need to put a reaction. We need to put a reaction force here, and then we can get the Gy equals to 16.31 Newton. So force needed at pin J to counter the force at Ij. And then means that Ij is... Okay, so we have known the Ij, and we need to find Jy to counter the force Ij. And then we can use sigma Fx equals to 0, which is the gauge J that we need to find, minus the JL that we have found the answer. So gauge J is 16.16 Newton. Since our assumption is compression and we got the answer is positive, means that our answer is true, that it is going compression. Okay, now we have reached to the end of the JIP FBD analysis. We are going to the last part of the analysis, which is the base analysis, base part. Okay, so for base part here, since our height and our width, our length is the same, which is 10/10, we can find the angles the same with the JIP. Since the answer is tan inverse is 1, tan inverse 1 is 45 degree. All angles are 45 degree. Thus, it does not matter if we use sin 45 or cos 45, since the result will be 0.707. Okay, so for now, we have given the known force is F3, and from the base we can find the F3, but we need to put all of the applied force, which is the F2 and F1. Since F3 got 4, we need to multiply by 4, and then we can find F3. So the F3 is 0.5831. So this is the force at the base, at the leg, and then we assume that all 4 parts have the same amount of force. Okay, so next we can analyze it one by one, just like how we analyze the counterweight and how we analyze the JIP. So we start from the pin at Q, and same goes to the last or the previous part. We can use the sigma Fy equals to 0 and the sigma Fx equals to 0, and then we can get the answer. Goes well to the section T, section S, section R, section O, section P, section N, section M, and until the section F, which is here. Okay, so for member RP, as we can see, since we have analyzed using the method of sigma Fx equals to 0 and sigma Fy equals to 0, we got the diagonal part of the member is 0. So it does not does not affect the base, since we got the result is 0. And same goes to the member at Mn. For member at Mn, we got the we use the sigma Fx equals to 0 method, and we got the Mn is equals to 0 as well. And with that, we can finally find all of the forces of the members of the base. Okay, so here is the more detailed one. Okay, so we continue to the section D. Same goes well, we use the same method as well until the section A. Here, section A, we can find the force member of GA, which is 1.17 Newton. And since our assumption is compression and we got the answer is positive, so it's true that the answer is compression. And then finally, we can find the member of JK and KG. Okay, so we need to analyze from section J, since we have known 2 forces. We have been given the force at BJ and JA. Okay, so we need to find JK. We can use sigma Fx equals to 0, which is the JK minus BJ, and then we got the JK is 1.76 Newton. Since our assumption is compression and we got the result is positive, so the answer is true, that it is going to positive. Now for the sigma Fy equals to 0, we need to put JY and AG. We need to put JY here because it will counter the force at AJ. So with that, we can find the JY is 1.17 Newton, and it is going to the pin, so it is compression. And then lastly, we can find for the section G. Okay, for section G, we have the KG, KG, IG, and FG. And with that, we can only use the method of Fx equals to 0, because we only need to find the member of KG. And then we got the answer is minus 1.15 Newton. So our assumption is going away from the pin. So we put tension, but because I got the result is negative, so it's going to the pin. And since it is going to the pin, so it means that the answer is in compression. Means that we have finished all of the counterweight FBD analysis. Okay, so this is the detail of the force body diagram of the crane arm. So here we have the four F3 forces, we have the F1 and the F2. Okay, so finally we have reached the end. Thank you everyone.